In physics, there are two types of quantities, scalars and vectors. A scalar is a quantity that does not have direction. For example, mass, time and temperature do not have directions, so they are scalars. A vector is a quantity with magnitude and direction. We can represent vectors as arrows. For example, if I walk 10 meters to the right, I could represent my change in position as a vector. Or if I am walking at 1 meter per second to the north, I could represent this vector on a map, like this. We live in a universe with 3 spatial dimensions. We usually call these dimensions the x, y, and z dimensions. Often we only deal with 2 spatial dimensions at a time, such as on a map. Sometimes, motion will be very straightforward, and we will only need to deal with 1 dimension. Whenever we have a coordinate system, we have an origin. And the origin is the location where all of the x, y, and z coordinates are 0. We can express vectors in terms of these coordinate systems. For example, let's suppose we are modeling a physical situation where we only care about an object's position in the xy plane, like this map. Since we know where the origin, or 0, 0 is, and the scale, we can represent any of the other points as vectors. If we look at the volcano on this map, it has a coordinate 2, 3. I'm going to use the symbol r subscript v to represent the position of the volcano. The squiggle that I have placed under r lets the reader know that it is a vector. Sometimes you'll see an arrow above the quantity, and it means the same thing. Or in typed text, the quantity will be bolded. So RV equals to 2, 3. Note, we always put the x-coordinate first. So we can express its position as a vector, 2, 3. We can also write this as 2x, and then we put a hat, like this, plus 3y hat. Rather than using x hat, y hat, or z hat, which represent the x direction, y direction, and z direction, often you will see I hat, j hat, and k hat. These also represent the x, y, and z directions. These quantities mean the same thing, but sometimes it avoids confusion with the coordinate value itself. It's also possible to have negative coordinates. So the position of the lake on this map is -3, 4. So the vector is -3x hat plus 4y hat. Now you should have learned what a vector is, how it can be represented as an arrow, and how to write down its components.